we'll now learn an application of combinations that you probably won't find intuitive at first, but the more you think about it, it'll make a lot of sense, and hopefully it'll make you appreciate once again the beauty of mathematics. And then you'll also know why, when we say, n choose k in combinations, why that's also called a binomial coefficient, because we are going to cover the binomial theorem. So before I give you the binomial theorem, let's understand the motivation for why it's even interesting. So let me erase that. Invert colors. So if we just had to multiply, I don't know, well, let's just take different powers of a binomial. A binomial is just a polynomial with two terms, right? So a plus b, well, a plus b to the 0, that's equal to 1, right? Anything to the 0 is equal to 1. A plus b to the 1, well, that equals a plus b. A plus b squared, that equals, and if you don't have a lot of practice doing this, you might be tempted to say a squared plus b squared, but you should correct yourself quickly and slap yourself on the wrist or the brain or someplace if you did that, because that's a plus b times a plus b. And then we could use the distributive property, or if you learned it this way in Algebra 1, you could use the FOIL property. That equals a times a plus b, right? Plus b times a plus b, which is equal to a squared plus ab plus ba plus b squared, which is equal to a squared plus 2ab plus b squared. That should be a bit of a review for you. And now it gets a little bit more interesting. What is, let me circle that just so we remember it. That's a plus b squared. What's a plus b to the third? A plus b to the third. And now this is starting to get complicated. This is equal to a plus b times a plus b times a plus b. Or another way to view it, it's a plus b squared times a plus b, right? This is a power of 3. So this was a plus b squared. So if we multiply it by a plus b, we'll get a plus b to the third. So let's do that. Let's multiply this times a plus b. So a plus b. So first let's multiply everything times b. So that's b, let me do this in another color. A squared b, right? That's a squared times b. Now let's do 2ab times b. So plus 2ab squared, right? 2ab times b, and then plus b cubed. And then we have a times a. Well, that's a to the a cubed, right? A cubed. None of these match that, so I'll put it in another column. A times 2ab, well, that's 2a squared b. 2a squared b. I'll put that out here. 2a squared b. And then a times b squared, well, that's plus a b squared, right? And now let's add up all of the terms. All we did is the distributive property again, right? We multiplied a times all of these terms and then added that to b times all of these terms. If we add it all up, I'll try to do it in order of, let's see, let's put the a cubed first. That's a cubed. And then, oh, actually, we already had this thing. This 2a squared b, I could have written it here. 2a squared b, because I had an a squared b here. So I just rewrote the 2a squared b here. So we have a cubed plus 2a squared b plus a squared b. That's 3a squared b. And then 2ab squared plus ab squared. Well, that's 3ab squared. And then plus b cubed. As you can see, that involved a lot. Just to take something to the third power. So we could, if we had the time, we could figure out what a plus b to the fourth power is, or what a plus b to the 10th power is. But as you could imagine, this would take you all day. So wouldn't it be neat if there were an easy way to calculate what a binomial is to an arbitrary power? And that's where the binomial theorem comes into play. And so in this video, I'm going to show you what the binomial theorem is. I will show you how to apply it. I will show you a trick or a technique that will make you seem like a genius. And then in the next video, I'll hopefully give you some intuition for why the binomial theorem actually involves combinations, why it involves actually the binomial coefficient at all. So what is the binomial theorem? Let me erase all of this. And you could confirm that the binomial theorem works for the ones that we've worked out up to a plus b to the third. You could work out a plus b to the fourth if you like to punish yourself. Let's see. Clear image, invert color. So the binomial theorem tells us that a plus b to the nth power is equal to, and I know this is going to look complicated at first, but we'll do a couple of examples and you'll see it's not that intimidating. It equals the sum from k equals 0 to n, right? This n is the same thing as that n, of each term is n choose k, right? We're going to keep incrementing k up from 0 to n, of x to the n minus k times y to the k. I know that looks complicated, but if we do a couple of concrete examples, I think it should make a reasonable amount of sense. So given, oh, sorry, this isn't, I was copying this down. This should be a to the n minus k, and this should be b. What I had written down before, that would be x plus y to the n. But if we have a plus b to the n choose k each term, a to the n minus k times b to the k. So let's apply this a couple of concrete examples, and we could even switch around the variable names if we want, just to show you that they don't have to be a's and b's; they can be anything. So what is a plus b? Let's do one that we otherwise would have found fairly difficult. A plus b to the fourth power. Well, the binomial theorem tells us that, let's see, the first term is going to be, well, what's n, first of all? N is 4 in this case, so it equals, let me fill in all the numbers actually. From k equals 0 to 4, of 4, choose k, right? Because k is what we're incrementing. A to the 4 minus k, b to the k, right? I just substituted the n into the binomial theorem definition. And what does that equal? Well, the first term is k equals 0, so that's 4 choose 0. So out of 4 things, I'm going to choose 0, and I'll show you in the next video why that works. Of a to the 4 minus k, well, the first term k is 0, so it's a to the 4th. B to the 0, right? So the b, that's just 1, so we can just ignore it. So what's the next term? Well, it's going to be 4 choose 1. And now k is 1, so 4 minus 1 is 3. A to the third, and k is 1 now. This is the 0th term, this is the first term, so b to the first. Plus, so as you can see, each term we go, the a term, the first term, whichever it is, it decrements. It starts at the power n, or in the fourth power, and then each term it goes down by 1. And then the second term, the b term, it starts at the 0th power, so it starts at 1, so that's why you don't see it there. And then each term it increments up. So then the next one, so I think you see the pattern, is going to be 4 choose 2, a squared, b squared, plus 4 choose 3, a b to the third, plus 4 choose 4. Now it'll have a to the 0, so that's just 1, b to the fourth. So we're done if we just figure out what these binomial coefficients are, and that's where they come from the binomial theorem. But we remember how to calculate that, right? In general, and hopefully you have the intuition on this, you shouldn't just memorize it. N choose k from our combinatorics is equal to n factorial over k factorial divided by n minus k factorial. N minus k factorial. So in this case, what's 4 choose 0? That equals, I know it seems very time consuming right now, although it's less time consuming than actually multiplying it out, but I'll show you a trick in a second that will amaze you. So this is equal to 4 factorial over 0 factorial times 4 factorial, right? 4 minus 0 is 4, a to the fourth, plus 4 factorial over 1 factorial times 3 factorial, right? 4 minus 1 is 3 factorial. A to the third b plus, I know this is getting a little tedious, but I think it's good to completely work through one entire problem, plus 4 choose 2, that's 4 factorial over 2 factorial times 2 factorial, right? 4 minus 2 is 2. A squared b squared plus 4 choose 3, that's 4 factorial over 3 factorial. And 4 minus 3 is 1 factorial. 1 factorial. A b cubed, and then 4 choose 4, that's plus 4 factorial over 4 factorial times 0 factorial b to the fourth. And notice, this coefficient is the same as that coefficient, this coefficient is the same as this coefficient, and then this one's in the middle. So let's evaluate them. And I'll switch colors. So 0 factorial, in case you don't know it, it's actually defined to be 1, which is a little bit non-intuitive because 1 factorial is also 1. But that's just something you should know. So 4 factorial divided by 0 factorial times 4 factorial, this is actually equal to 1. So the first term is just a to the fourth plus 4 factorial, that's 4 times 3 times 2 times 1, divided by 3 times 2 times 1, so that equals 4. 4a cubed b plus 4 factorial, that's 4 times 3 times 2 times 1, so that's 24, right? That's 24. Over, what's 2 factorial? That's just 2, so 2 times 2 is 4. So 24 divided by 4 is 6, so 6a squared b squared plus, well, this term is the same as this term, right? Just the 1 factorial and the 3 factorial got switched around, and you might want to think about that for a few seconds as to why that is. It should make a little sense to you. But that is, so it's going to be 4a b cubed. And it makes sense, right? Because this could have just been b plus a. A plus b and b plus a are the same thing. So it makes sense that there's this symmetry, right? That we have 4ab cubed and we also have 4a cubed b. Ignore me if you find that confusing. If you find it enlightening, all the better. And then the last term, 4 factorial. This term is the same thing as this term, and we've already figured out that equals 1. So plus b to the fourth. So it had a little symmetry. The coefficients are 1, 4, 6, 4, 1, and I'll show you in a future video that these are actually the terms of a Pascal triangle, which is another avenue to go in mathematics. But anyway, this was an application of the binomial theorem, and I realize I've taken 12 minutes so far, so I will do more examples in the next video. See you soon.